Hello friends, this is Vidhan. Welcome to my channel. Today we will see commutation relation of quantum mechanical operators. We know commutation relation of x and p equal to I h cut. But actually this relation is given by commutation of xp equal to del mn Kronecker delta mn into I h cut. It means that when we have x component of position and x component of momentum, then this quantity is equal to 1 and we have equal to I h cut. Since the components are same, it is the x component of position, it is the x component of momentum, so m equal to n. We know that del mn is equal to 1 when m equal to n, and it is equal to 0 when m is not equal to n. So when the components are same, it is I h cut. Similarly, when we have y component of position and y component of momentum, their commutation gives I h cut. Similarly, z component of position and z component of momentum will give us I h cut. Then what should be the relation when the components are different? If we have x component of position and y component of momentum, then since the components are different, this quantity will be 0, and that's why the whole term will be 0 and this is equal to 0. Similarly, if we have x component of position and z component of momentum, it will be 0. Similarly, y component of position and x component of momentum will give us 0, and y component of position, z component of momentum will give us 0. Similarly, z component of position and x component of momentum will give us 0, and z component of position and y component of momentum will give us 0. Secondly, we will see that we know xp equal to I h cut, and we also know that px, when you take the commutation relation in opposite way, xp, here we have px, it is given by minus I h cut, but the actual relation is given by the commutation of px equal to, again, Kronecker delta del mn minus I h cut. That means when m and match, the components match, then this quantity is 1 and we have minus I h cut. So it means when we have x component of momentum and x component of position, then only we have this quantity as 1, so we have minus I h cut. So py and y gives us minus I h cut, and similarly pz and z component of position gives us minus I h cut. But if you have x component of momentum but y component of position, then this quantity will be 0 since components don't match, so the whole term will be 0 and that's why it is 0. Similarly, py, px and z will give you 0. Similarly, py and x will give you 0, and py z here will give you 0. Also pz x will give you 0 and pz y will give you 0. So these are the relations.